The broadcast is now starting. All attendees are in listen-only mode.
Great, everyone. I'd like to welcome you back to another KevCAM night class tonight. Tonight, have Greg Payton with us as well to make sure we get all the information across to you guys. Hey, Greg, you with us?
Good evening, everybody.
And one of these times we'll catch Greg when he's actually home. But Greg, where are we this week?
This week I'm out in Anaheim, California.
Oh boy. Well, hopefully it's warmer than it is here in Minnesota.
Yes. We had low 70s here today, so it was quite nice.
Yeah. All right. So what we're going to be covering tonight is going to be HSS, Morph Between Adjacent Surfaces. And I do see all the regulars in here, so with that, we will just get the ball rolling right away for you guys. So 2 weeks ago, we covered Morph Between Boundary Curves. Now, Morph Between Adjacent Surface, to myself and at least everything that I can tell, is pretty identical to adjacent curves. The only difference is one's going off of a curve and one is going off of a surface itself. So what I'm going to do tonight is going to show you guys the difference with Morph Between Adjacent Surfaces, how it works. So for those of you guys that want to review this at a later time, you guys can come right to this video and see it. But we're going to be doing a lot of comparing back and forth between the adjacent curves as well. So, all right. So for this first initial cut, what we're going to want to focus on is this land right here, or this valley right here. So we can do right off of curves, but we're going to go right off these full surfaces. So first thing, hop over to our HSS here, and we'll do our Morph Between Two Adjacent Surfaces, which is second from the bottom. Now our geometry, same as kind of what we've been going through this whole HSS series. The drive surface is the surface that we'd like to cut. Now, our start surface, so not our start edge, but our start surface. So if we want to start over here, we can just grab that cylinder, as well as our end. We want it to end up over here. And we can go ahead and grab our tool here. And from right there, and hopefully I've been pounding this into your guys' head, that use this HSS as a building block. So we got our geometry, we got our tool. Let's go ahead and save and calculate. Let's make sure things are going where we want them to be going. So right here, we can see we have some jump up and jump downs, as well as our passes over here are straight edge passes. So what we can do is, to clean those up, we can come over to our length section, and any small slices, we're going to tell it to do a blend spline, as well as our large moves. And now we can see that we have one entry point and one exit point. We're not retracting up and down like you were seeing before. Now, if we get kind of a straight down view, all our connection passes right here, or our links between our slices, have a nice smooth blend spline in there, where before they were straight and jagged, and now we are fully smoothed out. So, kind of get a good view going all the way around here. And it is following the contour of our surfaces that we selected. So we told it that we wanted to go off this round surface right here, as well as the round surface over here. And we are seeing nice guided curves following that all the way through. Okay. Now, it does kind of look like the toolpath is going through our part here, which it's not, but just to double check, we can come over to our gouge check, and we'll tell it that not to gouge the drive surface. And for if we wanted to, we could tell it to do a check surfaces as well in a separate gouge. And we could tell it that we don't want it to touch that cylinder as well as the cylinder over here. Save and calculate. Okay. Toolpath, I'm happy with the way that toolpath looks. We know that we're not gouging. We are following based off of our surfaces that we have selected. Now, the last thing I'm going to do is come in here and go to my toolpath parameters here. And if I'm looking for that mirror finish, I'm going to bump this over to 5 thou, which is going to give us about a 2 RA finish, so we can go a little bit. Let's try 10. And now we'll have that beautiful surface finish in there. So let's go ahead and see what this is going to give us here. So now we can go ahead and play this through. And we'll see that we're starting on this side. And the only reason that we actually see it actually touching this cylinder over here is because when I roughed out this part, I left 15 thou on all the faces, floors, and surfaces. So that's why it is showing that we are cutting right there, but these cylinders are not down the sides yet. There we go. So we got nice surface finish in there. We can even hop over and see our radius looks good there. You see a line coming through the center here, but we can just verify that we are right up on size. So at that point, we could just be seeing graphical stuff. So yeah, we're at 1 thou accuracy, so it could just be graphical at that point. But that is a very easy way to do your morph between adjacent surfaces. Now we do have a couple other radiuses on here that we can hit while we're here. Since I have everything kind of set up the way that I would like, what I can do is make a copy. And then for our geometry, I'm going to grab this little chamfer right here. And then I can tell it that I want it to start on that surface there and morph its way down to this. Oops, I didn't show. Down to that surface there. And the only other thing that I'm going to be changing up in here is, let me turn off my gouge check right now because we don't have that check surfaces in there. But in my sorting, instead of doing a zigzag pattern, since we're doing a full circle here, I can switch this over to spiral. And we'll do a nice helix going all the way around that part. So now we got a nice spiral cleaning up going around this part right here. And we do have some jump up and jump downs here, but I think what's happening is large ball and mill trying to cut a very small radius. And then if we want to use that same tool, well, actually, let's make this a little bit smaller here. So now we'll get that nice clean surface cutting all the way around the top. We do have some repositions in there, and we could clean those up as well with our linking. It's going to be a large gap at that point. Instead of going up to the clearance area, we can just tell it to do like a follow surface. And now we got one nice lead in. Kind of zoom out here. One lead in over here, and then one exit move over here. So pretty simple and easy. So now let's kind of look at another part for you guys. Or Greg, do you got anything on this one?
Yeah, I was going to say, can you do a tool path from what we've seen from prior weeks, just the morph between boundary curves,
Sure.
and how it relates to that same first tool path where you did the morph between surfaces?
So let's go ahead and
That way we can see a overview of what one does versus the other.
Yeah. So what I'm going to do, just so we can see our tool path in here, I'm going to crank this back up to 50 thou here. So we can see our tooling lines in there. And now, let's go ahead and make a copy of that. We'll switch it over here. And our drive surface is going to be the same. We'll grab this curve as our start. And curve here. Let's do like a top-down view. Okay, so we got a top-down view here. Now, to me, there's a lot going on in here, but let's do this. Let's make it a little bit easier. Go off of Greg's idea from last week. I'm going to copy that tool. Then we'll recolor it to orange. So this way our tool path lines will show up as orange. Okay, so now we got the orange one is the morph between boundary curves, and the teal one is morph between two surfaces or two adjacent surfaces. Now, looking at this, the tool path is trying to get a, we go in the center, our tool path is looking identical. The only thing that I can tell a little bit of the difference is our step over is a little bit larger with the morph between adjacent curves versus the morph between two surfaces. Now you may ask, why is it doing that? And I'll have to do some research on that because I don't know, unless Greg, you know right offhand, why our gaps would be a little bit larger based off of boundary curve versus surface.
Yeah, I'm not familiar with it offhand. Do you have gouge checks on both operations?
Yep.
Yeah, can you turn the gouge checking off
Absolutely.
on each?
Same results.
Okay.
So, I mean, we are getting the same curvature with the tool path. Everything is identical from one to another. The only difference I see is we have just a little bit of a step over from one to the other. Because I can see right towards the center here, our morph between boundary curves is quite a bit larger. But if we get over to the corner area, we are pretty, well, yeah, it's still a little bit larger here, not nearly as much though. So a couple different comparisons for you guys there. I get some good angles for you, but like I said, the curved lines are following identical throughout the entire cut. So, all right. Maybe if we show it on gray, we can see a little bit better. But, all right. So let's hop over to another part here. Actually, I pull it up over here. 1 Second, guys. Oop, that's not what I wanted. So this one, I can remember from 2 weeks ago as well. So over here, we have our morph between two boundary curves. Now, what we can do is come in here, and we'll just make a copy of what we did. Well, let's start fresh, so we can get more examples for you guys. So do our HSS. Do our morph between two adjacent surfaces. So that's our drive surface. This is the surface we want to cut. I want to start from that surface and morph over to this one. And grab our tool. And save and calculate. Okay. So now we got our links going on right here. So we can go and clean those up. Much better unless we go down here. All right. So we got a nice tool path morphing from this surface right here to this surface over here. So if we do kind of a straight down view, our center is going right through the center, and the tool path is following the exact curvature of that surface that it's perpendicular to. So now if we kind of map it over, and let's do change our colors again here. So here's kind of the difference between the two. But once again, our let's see, our morph between boundary curves. So when we're clicking off the actual edge geometry right here versus the surface, is our blue line, where our morph between adjacent surfaces is our orange line. So you can see we got a little bit more orange lines. Kind of hard to tell, we got colors overlapping here. But we can see we're getting pretty similar tool paths of what's going on there. The only difference I see currently is we're just not doing a blend spline on our morph between adjacent surfaces. So we can just come over to our link section, switch it from direct to blend spline. And we'll get this one. Can I get one more? So now we got a nice blend spline going front and back. Except for our teal one, must be this one right here. Link. There we go. And for those of you guys that don't use that, definitely try it out. You will get, your machine will be so much smoother when it's going between those passes. And it's, you know, especially when we're coming in here and doing the finishing, we're going to have a little bit faster of a feed rate because we're not taking a whole lot of material off. You know, get that nice smooth movement going all the way through. So, any questions on this one? Silence in the crowd. All right, last part I want to show you guys here. So this one we also did with the HSS Morph Between Boundary Curves. So kind of show you different route to go here. We'll do Morph between two adjacent surfaces. Drive surface. I'm going to cut this area right here. We want to start up on the top and work our way down to the surface here. So we're not going to be doing a whole lot of morphing in this one, but give you some examples here. And let's go ahead and save and calculate. Okay, so we're starting at the top, working our way down. Now we are doing the zigzagging here, so we can go to our toolpath parameters, sorting, and switch this over to a spiral. And there we go. So starting at the top, following that upper geometry that we selected, and morphing its way down to the lower geometry down. And of course, if you guys are just looking at, you know, maybe where I see this being used the most is just doing the radiuses. So if we come over and we'll just tell it that it's that radius right there, our start curve is still going to be the same, but we want it to end right here. This works wonderful for doing these 3D fillets. So you can see you've got a nice toolpath working way all the way around the outside of the part. One starting point, one finishing point. And you get, if you wanted to flip these over, maybe you already selected your surfaces as a start edge, we can still come over to our toolpath parameters and flip our step over. So even though we told it to start up on the top, it will now start on the bottom and work its way up to the top. So if you guys ever run across that where you want to do a quick switch, you do have the flip step over button here, or we can come over to our geometry and just hit, we can come over here and do faces. I would have to switch these around. To faces 9 would be the start, and then faces 6 would be the end edge curve there. And then if we wanted to get real fancy, we could also do the make a copy in our drive. If we wanted to cut this bottom fillet here, save a calculation. And now we're doing that bottom fillet going all the way around as well. So, and you know, we may not be looking at, oh, there's not a whole lot of toolpath there, but that's all dependent on the radius that we're cutting down here, as well as the tool that we're using. That's all I got for tonight. Greg, you got anything that I'm missing here?
No, you pretty well covered it. And I'm not seeing any questions in the question panel either.
Okay.
For anybody who is watching the class and you have any questions, please put them in the questions panel. That way we can answer them for you.
Absolutely. And, you know, this one in particular, at least personally myself, it's not one that I use a whole lot, just because, as you guys know, I told you that my kind of go-to toolpath with HSS is the Morph Between Boundary Curves. But this is just another way of fine-tuning that toolpath to get the look that you guys are trying to achieve there. So, all right. Well, with that being said, next week, I think both Greg and I are out. Are you out next week, Greg?
As of right now, I'm not scheduled to be out.
Okay. So I will be in Chicago next week. So we won't have a class next week, but the week after that, we'll be covering the HSS projection user defined. And then week after that, actually, I think there's a skip because I'm going to have to fly out to Pennsylvania, but definitely come over to our SolidCAM website. Make sure you got the American flag up here so you have access to the, get to it here, KevCAM Night School, and sign up for those classes as well. And any ideas, definitely send those over to me via email, and we'll get your ideas added in there right away. We'll send you some SolidCAM swag as a thank you for sending your idea. But with that being said, wish everybody a great rest of your evening, and we will talk to you guys in 2 weeks to cover the projection. All right, everyone. Have a great rest of your night.
All right, good night.